Today's presentation is ideas into products. My space is physical products, but it's probably relevant to many other types, including software development. And the main learning objective, everything that we're going to be focusing on, is for how do you get the most out of what you invest in your product development efforts. So thank you for the great intro. I guess I don't really need to introduce myself very much. But basically in 2012, I was studying aerospace engineering. 3D printing hit the news. So I built my first 3D printer, switched over to manufacturing systems engineering, got a job in the university's rapid manufacturing and prototyping lab. And then several years later, some entrepreneurial endeavors and jobs, found New Hill Technologies, which was a prototyping business founded in the 90s. That was for sale. And so I purchased that and since rebranded it to Prototyping Tech. And I was just calculating, in the last 6 years, have delivered about 100,000 products between 3D printing, injection molding, cast parts, and CNC machined parts to our customers. So it's been a ride. In that, I noticed that the medical device space was the most interesting to me and personally meaningful. So I just went across the street to St. Louis University for finishing up a master's in biomedical engineering. They invited me back soon after to teach their additive manufacturing class. And like she mentioned, I'm now doing a year of product development. I'm on month 4 and not yet burnt out. I'll be sharing about some of the products that I'm working on in this presentation. So that's me. Would love to hear a little bit about you. With a raise of hands, who here has had a product idea? Probably everybody over the course of your life. Maybe you've had a product idea. Who here, just out of curiosity, has anyone brought a product to market? Okay, yeah, awesome. Who here is currently working on a physical product? Okay, sweet. Definitely keep those in mind. This is meant to be a workshop, so we'll have breakouts that would love for you to focus as much of this on your own, what's relevant to you. And then who here is just brand new to this? It's St. Louis Startup Week, so you're coming. Cool, great. Well, the way this presentation is going to be broken up, again, focus is you want to get the most from what you invest in your development process. And there are 3 kind of chronological phases that definitely have overlaps. First one, validating your market. Does anyone actually want this awesome idea, at least awesome to you idea, that you've come up with? Next, the meat of the presentation today is going to be iterative prototyping and research and development. That's my own favorite form of product development and is particularly useful to a bootstrapped founder that may not have deep experience in a field. So that's probably relevant to the folks here today. And then finally transitioning into the manufacturing. So the actual parts that get sold once your design is finalized. So developing a product can be a huge cost and effort. Any thoughts on how do you know your product will sell before you put effort into making it? Yes?
You do like market research and like business insights to find out whether or not that product has a market or has like a viable, addressable market, I guess you should say? Yes, there's lots of ways you can do that. I think from market research, maybe you're thinking more on like an industry list, or that's a great way. Any other thoughts? Talking to customers, yes, huge. Anything?
Competitors or whoever else is already in the field.
Absolutely. Does this product already exist? And maybe, so here's just a list of the different ways that you can validate market. A lot of us here, you're probably coming from your own personal experience. Like, oh, in my business or my work, or my hobby or my home, I have this problem. I have a product idea on how to solve it. Great place to start. Doing a web search, you would be surprised by the number of founders that have come to me and haven't searched if their product already exists. Marketplace research, if you've got a consumer-focused product, maybe Amazon is a place, and you can scroll down. There's a gold mine of critical feedback for what it already exists out there, pain points that you can harvest. Maybe you have an automotive product. Go to AutoZone, talk to the person behind the desk, walk down the aisle, see what's there. ChatGPT can be useful in my experience. It doesn't come up with innovative ideas, at least not yet, but maybe you've got a product for a Honda Accord and you need to guesstimate how many Honda Accords are there in the US or Missouri or St. Louis. Might be able to help with something like that. What kind of price point are you trying to hit? What are people already, if you need to solve the problem, how much do you have to pay today in order to solve that with one product or a suite of them? And then big one, conversations with your customers and also mentors. And I wanted to highlight the book, The Mom Test. How to talk to customers and learn if your business is a good idea when everyone is lying to you. And that's not implying any maliciousness. It's just saying people want to encourage you and be kind. And so if your friends or family, perhaps your mom, you say like, hey, look at my great idea. What do you think? They're going to be like, yeah, great idea. So Rob Fitzpatrick has gone through this process and really wrote this book for introverted technical founders. But it's useful for everybody. And it gives you a framework of how do you actually get truth. You want to know what's true. Like, yeah, validation and encouragement is really valuable, but right here in market validation, we want to know if you put a year of your life into developing something, is anyone going to show up and buy it? So don't rush into developing without knowing what already exists. And it can be really scary. I've felt scared typing in a Google search on this brilliant, beautiful new product idea I have, because I don't want to know someone's already made it. But when it comes time to actually start investing your time and money into something, don't be afraid. Go for it. You want to know, and you're going to find out either today or in a year from now. Yeah, a side benefit is that you learning the vocabulary and the context communicates a lot of competence when you're going to start talking to other partners, manufacturers, other folks in that space that are already there that you're probably going to have some interaction with. So, workshop, take a moment to think about one product that you would like to be considering as we go through the different exercises in this presentation. I find it's most useful if you're actually applying knowledge directly to a context. And if you don't have a product, feel free to take a look. I made a backpack when I was my undergrad. It's a very fancy wood and leather backpack. And if you can't come up with any idea on your own, maybe use this. Who would want to buy an artisan backpack? So just take a few seconds, lock that in for yourself. We'll be traveling through the hour with that. Feel free to write it down if you'd like. All right, next up, let's pair off for discussions. Ideally, someone sitting right next to you. We'll go through a number of quick conversations throughout. So everybody just introduce yourself. We're all friendly. I've met a bunch of you already. So in your group, in the context of your product that you've chosen, just take a second to think, what could you do to validate your market? And I'll go back to that last slide so you can see some of those different options. And if you've already developed a product, what have you tried? What worked? What didn't work? So in that context, we'll take just a couple minutes. The floor is yours again. All right, I hope that was fruitful. So that's that first portion on just starting to think about market validation. And I would love, I guess, does anybody want to share about product they're thinking about and one way that you're considering validating it? Or maybe something that worked in the past for you. Yeah.
Yeah, so I own a spice blend company. So
Uh-huh.
we've done a lot of market research.
Cool.
Sampling is really a big thing because we actually want to know, do all consumers like the product? So I've done a bunch of events the last little over a year, and we've shown that 1 in 5 people that sample actually buy the blend.
Okay.
It's huge for some of these events that a lot of people just sample and move on. And also just keeping track of which ones are doing the best, let anyone
Yeah.
that isn't doing so well. Like one of mine isn't doing great, so I thought about just doing like online exclusive for that.
Sure.
But the other ones have been going really well, so sampling's been really key.
Awesome. So you are having customer conversations. You already have your product developed. They taste it, and it's such a good match that they become customers right away.
We actually last weekend just sold out 1,000 spots. So.
Right on. Congratulations. Hey, you have a few snaps for. Congrats. Does anybody else want to give a quick mention of product you're considering and some way that you have or could validate your market? Yeah.
So a friend of mine, I'm going to use them as an example.
Uh-huh.
I don't personally have a
Yeah,
product,
all good.
And they're involving me in the process of working on it. So they want to start a stationery company.
Okay.
And so far they've tried, some market research, ordering from various different businesses just to see what kind of materials they're using, what works, what's going to be adding more of a personality into the brand they're trying to
Cool.
create. All of that type of market research goes into getting with different products. I think they're trying to gain that knowledge, and then it's looking at shipping, how is shipping and
Sure.
user experience and all with the website and all that type of stuff. What kind of personality do they have versus
Sure.
what she is trying to develop, all of that together. I think it's where she's in the very early stages of designing that product, and I think it's supposed to be more of that. If you've heard of Paper Republic, I don't know if anyone's heard of that,
Mhm.
but it's very high end in a way.
Sure.
But it's a very cool design where you can have refillable journals, basically. Yeah,
Cool.
they're it comes with one outside binder type thing that's leather. It's very personalized. It's embossed and all that, and then the inside is customizable completely.
Love
So
it.
she's trying to create multiple things, and then right now it's in the early stages, but it's cool to see the different market research process with all of this.
So your friend is founding a stationery company. And so it sounds like they've ordered early samples in order to do, again, customer conversations, see what people like. And yeah, awesome. Well, customer conversations are a very, very valuable place to get useful information. Also validating the logistics on time and cost of moving physical stuff around. It's harder to move atoms than it is to move bits. So physical stuff versus electronic stuff. Okay. One thing that often comes up at this point is the fear. If I share my idea with anybody, someone's going to steal my brilliant idea. And it's an important decision to make for yourself. In the time that I have been in this space professionally, I haven't personally seen anyone's ideas get stolen. It takes so much effort to develop something. And there absolutely are markets where ideas will get stolen in different ways or piggybacked off of. But even Medtronic would probably rather you and 10 other people like you to go through the whole development process and then acquire you afterwards. So it's a cost-benefit analysis of how much you're willing to share and how much you think you'll benefit from getting information from that. Also, there's some tools to protect yourself. Non-disclosure agreements, super common in my space for manufacturing. I don't think anything of it. I take it very seriously. I also wouldn't do anything differently. I'm not going to share about anybody's product idea if I'm making it for them. And then patents are a whole other thing. Probably something that comes a little bit later in your process once you have some differentiated intellectual property. However, patents can be really useful for marketing. Sometimes I wonder if that is their primary value. All right, the meat of our presentation today, iterative prototyping and research and development. How do you create experiments that teach you how your product wants to be created? first place to look, and you've probably already got this, it's intuitive. What core value does your product deliver to the user? You can think of the people who it helps, and you're probably already doing that if you've got customers that you're having conversations with. What need does it need to meet? What problem does it solve? Just a few different questions to help you frame that. And also, I'll share these slides later on. If anyone would like it, I'll put my email up at the end. You're welcome to take pictures, but don't feel like it's the only way. So what core value does your product deliver? Also, once you get there, which is probably a very intuitive place to start from, what are the existential threats that could kill your product from working? So like maybe there's a mechanism. My first product this year was this precision type of pump called a peristaltic pump. And can that mechanism even work? Well, I was able to buy one for 12 bucks off of Amazon. So yeah, the mechanism does work. But for me, I wanted to make it customizable and have the components 3D printed. And 3D printing, additive manufacturing, they are the different terms for the same word. Just snobby engineers like to call it additive manufacturing. So can I print customizable components of this and the product function? Can it be manufactured? And then also, is there a crucial price point? For this one, you can buy them for 12 bucks on Amazon, but there are also industrial pumps that are thousands or tens of thousands of dollars. So depends on the use case. For me, I knew I wanted this in a future product to be used in my business. Not as worried about a price point to hit, but maybe for a backpack, if I'm going through it and I realize I'd have to charge the price of a car to actually sell this thing profitably, maybe I'm not going to have any customers. So that can be an existential threat. Also, I like to think of waterfall conditions. So what can you define early on that you're going to be living with for the rest of your product development? One of these things could be materials. Another example in this pump, I started out with a clear plastic material for the components. And then as I got a little bit further, I realized it just wasn't stiff enough to actually function. So I ended up switching over to a gray plastic, printed on the same printer, same type of process. However, the tolerances are different. The actual part geometries are different. Subtly, but significantly different. So if you can dial in the materials, that's going to tell you so many things about the manufacturing process, operating temperatures, everything. And finally, what parts are you going to make in-house versus what can you purchase out of house? For me, again, this pump product, I knew I wanted to purchase out bearings. I wanted to purchase the electric motor. You know, I can buy these things for cents or the motor for 10 or 15 bucks. It costs me a lot more to make that. And if I can buy this thing off the shelf, a component off the shelf, I want to try and use that from day one if possible, because it's going to inform everything else in potentially subtle ways, but usually really significant ways. So we will pair off once again. You have your new friends. Make a new friend, please, if you'd like. And just note, what is the core value of your product? Again, this is probably intuitive. This is like what you came up with. And then what are these waterfall? I mixed up my slide. What are some of these critical features, waterfall conditions, or existential threats that you might want to be identifying early in order to inform your experimental design? So I'll give you all a few minutes, and then we'll do the come back together bell. Okay, some lively discussion. Really, really happy to see it. You're definitely going to get the most out of the integration time and the conversations, much more than just hearing me talk. So, love to see it. All right. So here's how I like to conceptualize the iterative design process for myself. So you've got some initial planning that's really setting the core needs of your product and trying to identify early on what you really need to know. What are some of those existential threats? So you start by setting the scope of a narrowed down experiment. What's the goal? What are you trying to learn? Then if you're in the physical space, design it, maybe with a CAD program or a different way. Fabricate it, and then test, analyze, and please document your process, because you're gonna go through a bunch of these things, and it's really easy to forget, even though it seems pretty obvious in the moment. I've got bags of previous prototypes for this pump. So here's an example. There's no snobbery allowed in getting the most out of your money, the most out of your time and investment. So when I was in grad school, there was a project for making a vibrotactile bracelet for communication. And there's a set of vibration motors that needed to be embedded in it. And I was starting in my CAD program, feeling all cool and like zoomed in and getting everything just right so I could 3D print a first draft. And then I realized like, I might be like zoomed in to the millimeter space. And so I decided to just like take a break and draw it out to scale on a piece of paper and cut it out and put it around my wrist. And I found I was way unrealistic with how tight I thought I was going to be able to get everything. Initially, this band was like that wide, half the width in my CAD program. And so I took about an hour to like really take some time. I got arts and craftsy and got out my markers, and it was fun. But more than that, I saved the remaining like maybe 6 hours of CAD design, and then printing it overnight, and then post-finishing it just to realize like, this thing isn't even gonna fit around my wrist. Let alone my friend who has a much smaller wrist, like, these need to be spaced tighter in that way. Anyways, a minimum viable experiment is probably a term that's been used, but I feel like I came it up. I'll try not to Google that. And again, there's no dogma, there's nothing you need to follow, it's just how do you get the most out of your time. And I think, just a quick pair off for a discussion. What is the first experiment you would want to do with your product? Cool, so minimum viable experiment, an analog for a minimum viable product. And it's really, we're trying to shrink down this scientific method of experimentation to find our truth and how our product wants to be made. So, I mentioned before, please do yourself the favor of documenting what you learn, your observations. For me, this often looks like an ugly spreadsheet because it's the fastest I can possibly do it. I make a bunch of different columns of things that I think I'll want to know, and then I'll record it, because once you're down 30 rows later, and you're like, how long did I wash it in an alcohol bath? Was it 8 minutes or 10 minutes? I'm realizing that's significant now. At least I forget everything. And this has saved me going back and running the same experiment a number of times. Also, taking pictures are quick, and they're so free now on our phones. Maybe there's a tiny storage fee once you get into the gigabytes, but take a bunch of pictures of your stuff, and it doesn't even have to be good pictures. Sometimes the out of focus one actually shows you what you need. So refrain from deleting things that aren't complete blur. And also, get out your Sharpie. If you've got a new product that you're making, and you've got an early prototype, you're not ruining it for anybody but yourself aesthetically. And I like to just make a physical mark with the version number that I've made, because sometimes things are visually identical, or you've got them in a big pile. I've tried to make these into like a fairly, or a chaotic, it's chaotic, it's orderly. It's just enough for me to be able to go back and find something. And on a backpack like this, maybe I would take it and use a pencil and draw on the inside here if I want to maintain some aesthetics. Okay, here's a quick question to you all. Your product needs a nylon bolt. You need one. You need to use it, and you'll need it in your final product. How might you make one of these? How might you prototype this?
Find someone who knows how.
Okay, find someone who knows how. I love where you're going.
Use your resources. I don't
Yeah. So when I taught this class on additive manufacturing, I was baiting people to say like, print it in SLA at this resolution in this material, when really there are a whole bunch of people that already make these. They make them way cheaper, they make them better quality, and so there are a bunch of online marketplaces. For example, again, in the physical space, McMaster-Carr, Grainger, they have this catalog of seemingly infinite numbers of sizes and shapes of bolts and springs and rods and bearings and everything. Uline is especially good for shipping supplies. DigiKey and Mauser are great for electronics. The quality can vary. I found things on eBay and Amazon when you can trust that you can reorder it. Sometimes you can find the best price, and if you've got Prime, it'll show up tomorrow or the day after. And if you're going through a bunch of different components, it can be really useful. So especially if you know you'll be able to use the exact same component that you're sourcing from McMaster, for example, for your final product. Maybe the price will change a little bit with volume discount, but don't reinvent the wheel if you don't need to. And when you're ordering, having options can save money and a lot of time. So for the peristaltic pump, there are a set of silicone tubes that go through, and basically a fluid comes in one side and it squeezes the fluid through and kind of pushes it out the other tube. And so the dimensions of those tubes is really significant. And as I was looking online, I realized, okay, I'm probably in a 4mm with a 2mm ID tube, but I'm not sure. Maybe it'll vary. Maybe I'll change my design completely. I found a seller on eBay that was out of China, and they had like $10 for shipping no matter how many you get. Each 3-meter long piece of tubing was a couple bucks. And so instead of just buying the one or maybe two sizes I thought I was going to go with, I just went and I got like 30 different sizes, because the lead time to wait another 2 weeks to get one more size, and I'm saving $1, but what if I have to drive to the hardware store? I'm burning fuel, I'm burning time. It can be really useful to have a bunch of different sizes for these simple items. And like this is just like a variety pack of different tiny bolts. If you need tiny bolts, they're pretty cheap. Often 5 of them cost $10, or you can get like 400 for $20. So depends on the thing, but don't hesitate to make a little bit mess in your workshop by getting all the resources you might need. So getting into 3D printing, my favorite nerd topic. Here are a couple pictures of the 2 different types of 3D printing you might be familiar with seeing. FDM means fused deposition modeling. Basically, you have a type of plastic that can melt and then reharden. So you're squeezing it through kind of a hot glue gun on a gantry, except for a different type of plastic. So that's one way, can be pretty clean. Another way that's higher resolution, but still pretty accessible from a cost standpoint. You can buy printers, both of these types, for under $1,000 these days. SLA uses a vat of goop, and that goop are short chain polymers or monomers that are fluid in their initial state, but then when you shine UV light on them, they cross-link. They become long chain polymers. They become a hard polymer, hard plastic. And with that, you can get a much finer resolution, so a much more precise part if you're working with lasers versus hot glue guns. So 3D printing, historically, the top 2 items, the form, how does a product actually look? is something that you were able to at least approximate. Maybe you're doing some painting or post-finishing with your parts, but form is something that can be useful with 3D printing. You can find the fit. Actually, when I was doing this pump project again, I was going to take a few extra days to get some bearings. So I just printed out bearings of the sizes that I needed so that I could just inform the next bit of decision in order to make a whole new prototype and save myself a couple days. Function really gets into the mechanical properties, in a lot of cases the mechanical properties of the part that you're manufacturing. So this is going to still be hit or miss with 3D printing because the types of plastics and the way that you process them are going to just give you different processing than a traditional molding process like injection molding. However, it's becoming more and more possible, and more items, whether you know them or not, probably have some 3D printed components inside of them. Next up, materials. There's a limited scope of materials. Mostly what we're seeing are polymers, plastics on the market, especially easy to access printers, but there's also metal printers, ceramics, you can even print chocolate, sugar sculptures, all sorts of things. And then the cost really depends. If you're comparing the cost of a prototype, the single piece might be $20 or $100, but if you injection molded that, it would be 20 cents for that piece. However, you've got months of lead time and maybe a $50,000 tool that you need to invest in. So cost is relative, and it weighs a bunch of different considerations. However, again, more and more it's becoming possible to both prototype with 3D printing and have some components that are actually used in production. Some local resources when you're getting ready to actually make your physical product. Made STL and Arch Reactor are two maker spaces in town. Made STL is a little bit more of a concierge service. They've got a few more tools. It's over in the Del Mar Maker District, and their membership is $125 a month. And I know they've been changing their model a little bit, but for the most part, that includes training in their wood shop, welding shop, metal shop, CNC machining, laser cutting, embroidery machine, 3D printers. There's a lot of tools over there. Arch Reactor is a little bit more of the hackerspace feeling. It's got a super strong community. It's a little bit less formal, and I know they've got a laser cutter that gets a lot of playtime. They also have a great wood shop, metal shop. They even have a forge. I've gone to several of their events. It's been awesome. Next up, there's a local 3D printer I've worked with called Printerior. They used to be in the Del Mar Maker District, but they just moved. So I'm not sure where they are right now, but they have developed, they do a lot of small scale or small part 3D printing, but they also have developed an awesome system with robotic arms that can print really large parts, like up to 9 feet. Which again, gonna be expensive. Piece price is gonna be expensive, but maybe you're saving yourself $100,000 tool cost to get in the door, to test it or to actually deliver it to a customer. So, actually let's just see how much time do we have? We'll pair off for a minute.
Technically, we're running until 10:30.
Okay. Okay. Well, let's do a really quick one. Again, coming back to your product, how might you approach physical prototyping? Are there any local resources that you want to engage in? Have at it. All right. Any thoughts anyone would like to share around your product or local resources, or how much you might just approach prototyping? Whether that is, yeah, go ahead.
Yeah, I just want to say another good space has 3D printing and some other makerspace
Yeah.
resources. The Clock Library branch at 40 Lindbergh, out in St. Louis County.
Which library branch?
The Clock Library.
Clock Library. Cool.
And they have some 3D printing stuff.
Awesome. Awesome.
You just have to pay for materials, like
Yeah.
a membership. There's also like a recording studio and a bunch of other like makerspace type of stuff.
Aren't libraries amazing? I feel like libraries are stepping up. Cool, thanks. I didn't know about that one. Any other
Talk
thoughts?
more about St. Louis U, the additive manufacturing, because last time I talked to them, they're still able to take on, small projects.
Which one?
I mean, at some cost.
For which
St.
company?
Louis University and additive manufacturing.
Oh, yeah. Gosh, I should have listed that. So there's
We
the,
mentioned it a little bit, I think, earlier.
yeah. St. Louis University has a Center for Additive Manufacturing, and they've got some awesome students on staff and some professionals that are leading that department. They can do 3D scanning. They've got some great 3D printing capacities, including MJF, if anyone's familiar with that. It's just a really nice type of 3D printer. So that's another resource.
They could also hook you up with a student that's doing like with CAD drawing.
Yeah.
And help
Yeah.
you kind of, because a lot of times you're like at the beginning, you're not even sure where to start.
Mhm.
They could also do a miniature version.
Mhm.
If you got like a big thing, if you want to convert it to a little thing, that's kind of fun.
Love it. Thanks for bringing that up. Yeah, SLUCAM is awesome.
Okay, that's it.
All right. So iterative design can be a bad fit when you actually need your whole product finished before you can get a valid result. That can be the case. Or if what you really need is an expert, like if people just know this and you're trying to iteratively develop something that is like hard but already exists, like try and find an expert. And sometimes you don't know. You don't know that somebody knows. But if you can, you'll save yourself a lot of cost. And doing this iterative process is inherently uncertain. You're doing this experimental process to find out what you don't know. You don't know what your result's going to be. So it can introduce some cost and timeline uncertainty in your development. However, best use when you have access to fast, cheap prototypes. That could be paper cutout, that could be a 3D printed part. Applications where there isn't expertise internally, or maybe you can't access expertise on this. This can be a way to kind of break down what you need to know with a scientific method type of process to test and find out what's true. A side benefit, you can uncover unanticipated failure modes. Some things just become obvious. Like initially when I had this backpack, I thought the strap should be about that long. And so you don't have to make the whole thing to realize like, oh, my elbow doesn't like even fit through this thing. Like I can figure that out with a yardstick and a piece of string. And you can also make accidental discoveries. Often you'll find, or I've found, like, oh, this actually fits into that, or I can use the same bearing here as over there. And some things, there's something magical about actually having your hands on a physical part to make it make sense. Lastly, I really appreciate the business writer Jim Collins, and he has a concept called bullets to cannonballs. So he's like, if you're in a sailboat and the pirates are coming up behind you, and you only have enough gunpowder for like a few cannonballs, maybe don't just load them in, Hail Mary it, and shoot all cannonballs at the same time. Instead, portion out some of your resource, some of your gunpowder, and shoot a couple bullets, like just to calibrate which angle you should be at, which trajectory you should take. And then once you've got it kind of dialed in, then pull the trigger on a larger investment. So this brings us to final phase, manufacturing for production. And I would encourage all of you to really think about this, especially if you're working with a manufacturer versus buying some bearings off of Amazon. Think of this as a partnership. Everyone's got to win here. And they want you to win because that means more money for them. And you want their life to be easier too. So I'll keep this quick since we're running out of time. Don't be shy about quoting a bunch of folks. And I love to do this in one big burst so that I can be like, oh, it's not you. I'm just waiting on some quotes to come back. I've got this open already. For a recent part, I got quotes between a dozen different suppliers between $5.36 a piece to $34.65 a piece. And no one was trying to rip me off. They just have like a different facility that's built for different efficiencies. And this was the exact same part, the exact same quantity, the exact same material on the exact same machine. So the cluster was around $10 to $12 a piece for most of these guys. And to be fair, the $5.36 may not be my best option. They might be. They're like kind of a big one. It was hard to get them on the phone. The $10 to $12 folks, probably the sweet spot for this product. But sometimes the cheaper option is better and it is faster because they're built for it and they can just deliver. And like I was talking about with Adam, you cannot forget the cost and time involved in logistics. So always be asking about lead times. Here's a quick list. I won't go into this, but generally, if you're quoting out a specific part that you've designed, the manufacturer needs to know the part design. That might be a CAD drawing. It could be just a drawing. Maybe it's a sample of what you already have. They're going to want to know the materials that you need it made out of, the manufacturing process. Is there an assembly process? What production quantities or annual volumes? This is very important to them because this means how much money are they going to make over time. And maybe do yourself a favor of like giving them the best case scenario and be a more attractive potential client. They want to know what lead time you need. Often I'll be asked a target price that I'm aiming for. I don't usually volunteer this out of the gate, but once I've kind of dialed it down, maybe I've got a few of those folks in the $10 to $12 range. I'm like, hey, I'm seeing somebody for $565. I don't know if it's true, but I'd like to work with you guys. I really enjoyed communication. Is this your best price? And so it can be a negotiation. You're not trying to beat them down on price, but just like, this might be the first time they've quoted that type of part, and they don't know. And then they want to know any special requirements up front. Maybe it's a medical device that needs to be manufactured or processed in a clean room. If they don't have that, save them the time, save you the time, and let them know up front. And again, feel free to ask for a non-disclosure agreement or any way that you don't want your information disclosed. Super common, may not be necessary, but if it makes you feel comfortable, definitely feel free to ask. Once you've narrowed it down, the suppliers you want to work with, if you can, do an in-person visit. Probably you're not able to go to, or I wasn't able to go to all 12 of these manufacturers that are spread out around the United States. But before I source with one of them, I will go and do a factory visit. And this project warrants it. But you can learn a lot about the facility, and all manufacturing facilities are not the same. And you may not know the specifics of a process, but you can definitely see if it's disorganized or dirty. And that is the case sometimes, and maybe that's fine, and maybe that's just like part of the operation. They throw off a bunch of dust in their process, but there's just a wide range here, and it can show their professionalism. And the biggest part of an in-person visit is building relationship. Building relationship and being able to communicate more effectively. This happens every time for me. This is why the salesperson always wants to come and meet you when it's that kind of relationship. It just matters. So I think we don't have time for this paired discussion. Sorry for the false start, but you can do that on your own. In our last 4 minutes, just a few other tips. If you're working with a customer, recommend that they validate their market. Again, you want them to know. Break down projects into paid phases. This is so useful, and it values your time as a product developer, because if someone walks away before you've actually made a prototype, but you put in maybe 10, 12, 40 hours into a design process, and they're like, I don't think so, be like, oh, this was the initial, like, we'll do a phase thing. It protects both sides. So they get what they want and don't commit to something they don't need to. When customers tend to be a bottleneck in communication, I really like, these are mostly quick tips. I like to put things in like a Google Doc or something and be like, hey, I'm gonna put all of the experimental data, or the files are gonna be updated here, let me know. And, oh yeah, that's the second one. The first one, if possible, when it's appropriate, frame communication to customers of, hey, if this is a problem, let me know. Otherwise, I'm going to proceed. And often my customers aren't like, he's trying to get away with it. They don't want to have to respond. They're busy too. And especially in unknown space, things will always take more time than you think. So try and factor that in. If it's the best possible speed, even though it's so tempting to be like, yeah, I can do that in 5 days, just give yourself a little bit of buffer at least. So, to review, validate your market, explore existential threats and define waterfall conditions, utilize iterative design to find the truth in new space if it's appropriate for you, and partner with your manufacturers. So maybe we have a little bit of time for Q&A, and feel free to reach out to me via email or LinkedIn if you'd like the slide deck or to talk about a project.
Hi, my question is.
1 second, since
Oh.
we're recording this, I want to make sure that it's.
Sorry.
You said you would send the slides?
Yeah, feel free to send me an email or reach out on LinkedIn. I'd be happy to share the slides. Yeah.
Hello, my name is Kendra, and my question is, I heard you talk a lot about designing the products yourself, hence like 3D printing and
Yeah.
things like that. What is the situation where there are pros versus cons if it's worth trying to build every component yourself or most of the components versus just finding a manufacturer? Like you said the product exists already, so maybe you can link up with that existing products manufacturers and say, hey, I want to tweak it a bit. Because the products that I have, I'm in the hair industry.
Yeah.
And I deal with people with hair loss, and a lot of the toupees and hair toppers for men and women are very limited and don't include a certain market of people. And I've traveled extensively throughout Asia, and I've visited and sourced all of my own manufacturing.
Cool.
And instead of me trying to do that here, because the labor costs will be insane, it's better for me to just link up with them. They're already creating, they have the infrastructure, and to just do it. So basically, what are the pros versus cons versus not reinventing the wheel versus doing it yourself?
Yeah, great question. And what an awesome and worthy product to be developing. I'm sure it makes a big difference in a lot of people's lives. I find that in the prototyping phase, when I'm trying to figure out if a thing will work or could work, I like to save as much time as possible. And so that usually means not waiting the lead time, or maybe there's communication challenges or communication delays if you're in a significantly different time zone. So if you can involve your manufacturers early in that process, some of them don't want to talk until they can quote a part, but a lot of manufacturers, especially ones that are going to be really happy to work with entrepreneurs, they would love to help you develop your product in a way that actually can be manufactured. So I think there's a hybrid possibility, and it depends what resources you have in-house or in your home, literally, if you're like me, starting out. I would definitely benefit from as much as I can from other people's experiences, and if I know it's going to be manufactured by another vendor, I'll try and make that connection as early as is appropriate. I don't know if does that answer your question? Pros and, yeah.
Somewhat.
I guess it's a little bit of an it depends on my side, and ways to factor that, really value the timeline, because timelines can blow up, especially with logistics. But also make sure that you're getting something that, you're creating something that can be made.
Yes.
That's what I've got. Yeah, great question, thank you. Any other questions?
We'll do one more.
First of all, thank you for a great presentation.
Sure.
I was wondering, so we talked a lot about manufacturing. I was
Yeah.
wondering if you had any advice on the distribution part of that.
That's outside of my experience. And it seems, yeah, you should talk to Adam, doing a global supply chain logistics. But it seems like there are a number of ways to get, you're already in touch with your customers, with your spice line. There are a number of ways that are accessible to entrepreneurs to go to market. Shopify is like an online storefront that you can build out pretty quickly and easily. There are other online marketplaces like Etsy. I think you can list your products on Amazon. I don't know what it's like to work with either of them. But I think tell me what you learned. It's a little. I'd love to learn from you. I don't have experience with marketing and go to market so much. Yeah.
But yeah, so so basically, I'm trying to focus on distribution because
Mhm.
sorry. I'm trying to focus on distribution because I've been given a lot of interest, and I have a co-packer that can manufacture the blends,
Mhm.
but again, it's getting the blends from the co-packer to a bunch of different locations, which is even harder with a food-based company with those temperature requirements
Yeah.
and a bunch of those
Yeah.
sort of aspects.
Yeah. If I were in your shoes, I would look up other distributors and reach out to them, and maybe other folks specifically in food, because there are going to be some special requirements with the FDA for storage, like you were saying.
Thank you.
Yeah.
Awesome, folks. Let's give Josh a round of applause. Thanks so much, Josh. That was amazing. We're going to break for